9.6, we dig back into slope-intercept form. Today we'll graph linear equations using the slope and the y-intercept. Slope-intercept form is an equation written in the form y equals mx plus b. Big equation here. M represents the slope, y represents the y-intercept, or sorry, b represents the y-intercept. Basically what the y-intercept tells you, it's where the y value crosses the y-axis. It's known as a starting point. So this here in our example would be the y-intercept. It crosses your y-axis at that given point. What we need to know about y equals mx plus b, well, this is in slope-intercept form. First and foremost, for things to be in slope-intercept form, y is alone. Y is the only thing on that side. Mx and b are on the other side. Secondly, for things to be in slope-intercept form, m represents slope. Okay, slope is next to x. Your slope is written next to x. And last, b, as mentioned before, b is the y-intercept. It's where it crosses the y-axis or your vertical axis. In our first example here, we need to find the slopes and the y-intercepts of the graph. It says to state the slope and the y-intercept of the graph of the given equation y equals 3/4 x minus 5. Remember, this was slope-intercept form here, y equals mx plus b. So if you kind of line things up, say to yourself, is this in slope-intercept form? Yes, it is, because y is alone. What we need to pull out in this problem is your slope, m. Well, what is m? M is next to x. M is 3/4. So your slope in this problem is 3/4, which is telling you your line is increasing because it's positive. Your b value is -5, so it intersects your y-axis at -5. Example 2, same scenario there. I want you to play it through just like we did in example 1. I want you to go ahead and pull out your m and your b. So in example 2, we note that y there is by itself. We find out our slope is 1/4, which is next to x, and then our b value, our intercept there, is -2. In our next example here, example 3, it says state the slope and the y-intercept of the graph of the equation 2x plus y equals 8. 2x plus y equals 8. Notice, hint, this needs to be alone. Y needs to be alone. It needs to be in slope-intercept form. I couldn't just take out of my equation and say, oh, m 2 is next to x, so therefore my slope is 2. Doesn't work that way. You have to go ahead and put things into slope-intercept form. In order to do this, subtract 2x from both sides, and we get y equals -2x plus 8. That's a positive 8 there. So now we can go ahead and take out your m and your b values, but it has to be, y has to be by itself. Now we can go ahead, -2 is next to x, so -2 is our slope. Our b value is a positive 8, so that's how we would do that problem. Example 4, very similar to example 3. Again, get y by itself. Go ahead and work through example 4 and check back in. So once we have this, go ahead, get y by itself. So we subtract 3x from both sides, and we get y equals -3x plus 5. So our m, our slope, next to x is -3, and our b value is positive 5. So our m is -3, our b is 5 once we get y alone. What we'll be doing with this information today is basically graphing. So here's the steps in order to graph. Normally what we've done in the past is we've made a table, x, y, put in values like 0, 1, and 2, got out y values, came up, put our ordered pairs in, and then we went ahead and plotted those points. Well, if you know the slope and you know the intercept, you can plot things without setting up tables. It's much more efficient. Here's your steps. Step 1, find the slope and the y-intercept. We've done that in the previous problems. Next, graph the y-intercept. Third step, use the slope to locate a second point on the line. Keep in mind if the slope is positive or negative. Okay, we know that lines that are positive increase. Lines that are negative decrease. And then step 4 is to go ahead and draw a line through the points that you have. So first things first, we look at the problem y equals 2/3 x plus 2 using slope and y-intercept. We notice that y is by itself, so I'm going to go ahead and pull the slope out, which is next to x, and that is 2/3. My b value, my intercept, is 2. That's step 1. Pull those values out. Step 2 is to go ahead and plot your y-intercept. Remember, it's where it crosses the y-axis. There's our y-axis. It crosses at 2, so I'm going to put a plot there. Third step would be to go ahead and use our slope. Our slope is rise over run. So our rise is 2, our run is 3. Now, what I would do is I'd come up 2 units. Don't put a plot because I need to go over 3 units. Now I need to determine, do I go to the left or to the right? Well, if I went to the left and put a plot here, my line would be decreasing. So that's not where we want to go. We want it increasing. I know that it's increasing because my slope is positive. So what I need to do is I would come up two spots, over 3, put a plot. I could also go down 2 because it's same up and down. There's a rise, and I could go over 3 and put a plot. So I'd actually have these 3 plots in line, and then I could go ahead and use a straight edge to construct this linear line. And that's how I would graph using the slope-intercept form of graphing. Example 6, same thing. In this problem, we have y equals negative 1/3 x minus 3. Again, y is alone, so I'm going to steal out my slope, which is negative 1/3, and my intercept is negative 3. So there's our first step. Identify that. Step 2, plot your y-intercept. Y-intercept is negative 3. Negative 3 is down here. Now we're going to use our slope. Up 1 over 3. Remember, line needs to be decreasing, so it should be going this direction. So I'm going to go up 1 unit, that's my rise, over 3 units, plot it. And I could keep using my slope here, and I could put multiple points here. I could go up 1, over 3 more, plot it. I could go from my intercept here, I could go down 1, over 3. I can keep using my slope to get multiple points to graph that line. Now, really all I need is 2 for the slope-intercept form of graphing, and then I construct that straight linear line. So go ahead, use a straight edge and construct it. Notice my linear line is nice and long, goes all the way through that graph. It helps when we have to identify intercepts. Last question here, a kind of realistic one. It says graph an equation to solve problems. Movie rental. A movie rental store charges $4 to rent a movie. If a movie is returned late, the charge is $3 extra per day. The total cost x is given by the equation y equals 3x plus 4, where x represents the number of days the movie is late. We need to graph the equation. So in this case, x is talking about days late. Y is going to be your cost for having that movie if you return it at later times. So I'm going to go ahead and graph this, and I'm going to use that equation there, y equals 3x plus 4. We need to be careful here and make sure that we know what our intervals are going by. So it looks like here in our graph, our y-axis is really going up by 4s here. It looks like it's 8, but it's going up by 4. So I need to plot my y-intercept. My y-intercept is 4. There's my plot. My x intervals are really going up by 1s here. It looks like it's going by 2s, but it's going by 1s. So what I need to do is go ahead and, from my y-intercept, go ahead and use my slope, m, which is 3. Well, it's really 3 over 1. 3 is your rise. 1 is your run. So I need to go up 3. I can't go all the way from 4 to 8 because that's up 4. So I need to go up 3. So I'm going to go up 3, and then I need to go over 1. There's my plot. So now I have my 2 points. I can construct my linear line from those 2 points, and there we have it. That helps us, basically it helps us determine from the number of days late, and I'm going to go ahead and label this. This is X values talking about days, and this would be talking about cost. So we'll label that. So if you put your finger on 1 day and you went up and hit that line, you would say that your cost is about $7. Next part, it says movie rental. Describe what the slope and the y-intercept of the graph represent. Your slope, M, your slope represents 3 over 1. Remember, it was 3. 3 is dealing with the y value, 1 is dealing with your extra value. So that's basically saying $3 per day late. So you owe $3 per each day late. Your b value, your y-intercept, remember your y-intercept is basically your starting point. Basically that is your initial cost of the movie. So when you first purchased that movie, it was $4 prior to any late days. The last question says, is the total cost proportional to the number of days the movie is late? Explain. Well, there's 2 explanations that you could actually take here. One explanation that works, since it's already graphed, is you can say no, that the graph is not proportional, as it does not go through the origin. Remember, proportionality and direct variation go through the origin. The second way you could describe this is go ahead and set up a table. We know that for 1 day late, so X days, 1 day late, you're going to spend $7. For 2 days late, you would spend $10. Then if you go ahead and look at your ratios here, remember it is y over x, so it's basically 7 over 1 and 10 over 2, and this would reduce to 5 over 1. Those ratios are not the same, so the ratios also show that this is not proportional. This will conclude our lesson 9.6, slope-intercept form of graphing.